Question 20. Two buildings are 70 metres apart. One building is 10 metres tall, another building is 15 metres tall. A line can be drawn from the top of each building to the bottom of the other. These two lines intersect at a point B, 0.6 metres above the ground. I'm actually just going to change that to 6 metres above the ground. 0.6. I think 0.6 seems very low to the ground in comparison to everything else being like 10 or 15 metres up in the air. And I think maybe if I use 6, I end up with the solution in the back of the book. So I wondered, they mean 6 metres rather than 0.6 metres. Anyway, either way, I'm changing the question to 6 metres. If you see an error in my work, just let me know. But I think the method is pretty okay for what I'm doing. So, first part anyway, I have to draw myself a sketch, but I would be doing that anyway. Not a chance would I be doing this question without a sketch. So in the question we have a building, it's 10 metres tall. I have another one, 15 metres tall, and they're supposed to be 70 metres apart. Clearly my diagram is not going to be to scale. Whoops, so that's 15 metres. You can join the bottom of one building to the top of the other. And really I should be using a ruler even in this for myself. Well, especially since they asked me to do it as part 1. I should definitely be using a ruler. And the second one goes down to the bottom of the opposite building. Okay, so we have something like that. And the only other bit of information is that they are 70 metres apart. Now, I don't know whether to put the 70 there, or there, or maybe there. Anyway, I'll figure it out as I go. First thing I'm not going to put in that 70 just for a minute, because I want you to be able to see that I have similar triangles here, because these two buildings are, like, think about it, both of them are straight up, so parallel lines, which means that is equal to that. They're vertically opposite angles. That is equal to that, because, you know, if you turn it sideways you can see your Z, and that, this one here, is equal to this one here, and again it's the backward side this time. So I definitely have similar triangles. Okay, how is that helpful? Maybe not. I bet you have more similar, I bet I have more similar triangles. So if I feel like I'm getting stuck here now, I might put in my 70. If I put in my 70 down here, it creates a triangle down here. Don't know if that one's going to be similar. I'll put my 70 maybe here. I'm just putting in a line. You can put it in anywhere. So if you want to redraw it and have the line down here, I'm only kind of sketching them in very lightly for myself to start off with, to see, do I create other triangles, because maybe those triangles will be similar also. The reason like that I went for similar triangles here is maybe sides are in ratio, and I'll be able to figure out what they want in the second part of the question. Because I have the first part done already, draw a suitable diagram. They want me to calculate the distance between this point, so point B, and the two buildings. So they want me to calculate the distance from there to there, and there to there. So maybe that is the best probably spot for that. I'm going to put in my right angles. Now, what other triangles are similar? So I think these two are going to be similar, because there's a right angle, that and that are equal, which means the third one automatically has to be equal. So I might just put that there. That and that are going to be equal, so those two are similar. Now, this point here is 6 meters above the ground, which means this is 6 meters here. If this is 6 meters above the ground, it means that this is 9 meters here, I think. This one here, so I'm just going to highlight them. This triangle here and this triangle here are similar. Now, the 9 meters is across from that. So 9 over 6, I hope you can see that as I'm going, is equal to, God, I don't have anything. Oh, wait, look here. If I call this x, this here is 70 minus x. And this is opposite the double line. So x over, opposite the double line, 70 minus x. Okay. So I hope that's clear enough. If it's not, I don't really mind doing it again. So I started with a big triangle, and across from this angle here is a 9. So I go to the small triangle, and across from this angle here is the 6. So 9 over 6 is equal to, back to the big triangle, across from the double kind of marked angle is x. Across from the double marked angle here is 70 minus x. And the reason I know that is because the whole line is 70. If I call this x, this has to be 70 minus x. Now I should just have algebra left. 9 times 70, that's 630. Minus 9x is equal to 6x. That's 630 is equal to 15x. 630 divided by 15, 42. X is 42 meters. So if that's 42 meters, that has to be the rest. My diagram is terribly out. But anyway, 70 minus 42 is 28. Okay, maybe not too bad. No, it's not. It's not out. It's not great. So what do they ask? Calculate the distance between this point and the two buildings. So from here to here is 42, and from here to here is 28.